Welcome back, folks. Yuvraj here. Have you ever gazed at the night sky and seen countless twinkling lights? Those are stars, giant glowing balls of hot gas scattered across the universe. They look tiny because they're incredibly far away, but many are much bigger than Earth. Imagine a huge ship on the horizon. It looks small, but you know it's massive. That's how stars appear to us. Stars shine because of nuclear fusion in their cores, releasing tremendous energy as light and heat. This light travels for years across space before reaching our eyes, making the stars appear as distant twinkles. The closest star to us is the sun, which gives us the light and warmth we need to live. Without the sun, Earth would be a frozen, lifeless world. Even distant stars are important. They create new elements, the building blocks of planets and people. When you look up, you're seeing cosmic factories that helped create everything around you. Every star has its own story. Born, living for millions or billions of years, and eventually dying. By studying stars, we learn about the universe's history and our place within it. The journey of a star is a tale of gravity, gas, light, and time. Let's begin our own journey to understand these incredible celestial wonders. The universe is full of stories written in starlight. Ready to explore? Not all stars are the same. They come in many sizes, colors, and ages. Some stars look reddish, others bluish or yellowish. These colors reveal their temperatures. Red stars are coolest, yellow like our sun are warmer, and blue-white stars are the hottest. The smallest, most common stars are red dwarfs. They burn fuel slowly and can live for trillions of years. Medium-sized stars like our sun are yellow dwarfs, shining for billions of years. Blue giants are massive, hot, and bright, but burn out quickly, just a few million years. Supergiants, like Betelgeuse, are so enormous they could swallow several planets if placed where our sun is. A star's size determines its color, temperature, lifespan, and how it will die. Small stars end quietly, while massive ones go out in spectacular explosions. Understanding these types is the first step to learning a star's life story. Each star's fate is written by its mass. The universe is a tapestry of stars, each with a unique destiny. Let's discover what happens next in a star's life. The adventure continues. Stars are born in stellar nurseries, giant, cold clouds of gas and dust called nebulae. These nebulae are beautiful, glowing with color when lit by nearby stars. Gravity pulls clumps of gas and dust together inside a nebula, forming a growing ball called a protostar. As the protostar gathers more material, its core heats up from the pressure. Eventually, the core becomes so hot and dense that nuclear fusion begins. The star switches on and starts to shine. A powerful wind from the new star blows away leftover gas and dust. The protostar becomes a true, stable star, ready for a long life. Every star's journey begins in these cosmic nurseries. The birth of a star is a story of gravity, heat, and transformation. From darkness, a new light emerges. The universe is constantly creating new stars. Let's see what happens as a star grows up. Once a star starts shining, it enters the main sequence, the longest, most stable part of its life. Here, gravity pulling inward is balanced by the outward pressure from nuclear fusion in the core. Stars spend about 90% of their lives in this phase, steadily converting hydrogen into helium. Massive stars burn fuel quickly and live short, brilliant lives. Small stars burn slowly and last for billions or even trillions of years. During this time, the star's appearance changes very little. But eventually, the hydrogen runs out, and the balance is lost. The star's stable adulthood ends, and dramatic changes begin. What happens next depends on the star's size. The end of the main sequence is the start of a star's final chapters. The universe is about to get a lot more interesting. Let's see how stars say goodbye. When a small star like our sun runs out of fuel, it doesn't explode, it transforms. The core collapses, heating up, while the outer layers expand, turning the star into a red giant. The red giant grows so large it could swallow nearby planets. Its surface cools and glows red, while the core fuses helium into heavier elements. This phase is brief compared to the star's main life. Eventually, the star sheds its outer layers, creating a glowing planetary nebula. Left behind is the hot, dense core, a white dwarf. A white dwarf is incredibly dense, slowly cooling and fading over trillions of years. No new heat is produced. It's like a hot coal cooling in the dark. This is the gentle farewell of a small star. Even in death, stars create beauty in the cosmos. But for massive stars, the ending is far more dramatic. Massive stars end their lives with a bang, a supernova. When fusion stops, the core collapses in a split second, triggering a colossal explosion. A supernova can outshine an entire galaxy for a short time. The explosion blasts heavy elements into space, seeding the galaxy with the building blocks for new stars and planets. Supernovae are both endings and beginnings, recycling material for future generations. The calcium in our bones, the iron in our blood, all forged in ancient stars and spread by supernovae. In a very real way, we are made of stardust. The death of a giant star is a key part of the cosmic cycle. From destruction comes creation. The universe is always renewing itself. But what's left after the explosion? Let's find out. After a supernova, the core's fate depends on its mass. If it's massive but not extreme, it becomes a neutron star, an object the size of a city but heavier than the sun. Neutron stars are incredibly dense and spin rapidly, sometimes sending out beams of radiation as pulsars. If the core is even more massive, gravity crushes it into a black hole, a point so dense that not even light can escape. Black holes are invisible, but we detect them by their effects on nearby stars and gas. Gas spiraling into a black hole heats up and glows with X-rays before vanishing. Neutron stars and black holes are the strangest, most extreme ends for massive stars. They challenge our understanding of physics and the universe. These remnants are cosmic mysteries, waiting to be explored. The story of a star doesn't end with its death. Sometimes, it becomes something even more extraordinary. The universe is packed with star secrets. Our galaxy, the Milky Way, has hundreds of billions of stars, and there are trillions of galaxies beyond. That's more stars than grains of sand on Earth. When you look at stars, you're looking back in time. Their light took years, even millennia, to reach us. Some stars you see tonight may have died long ago. Most stars aren't alone. Over half are in binary or multiple systems, orbiting each other in cosmic dances. Some pairs are so close they share material, creating spectacular sights. Stars don't actually twinkle. The effect is caused by Earth's atmosphere bending their light. In space, stars shine as steady points. The universe is full of wonders, many still waiting to be discovered. Every star has a story, and every night sky is a window into the past. The more we learn, the more mysteries we find. The cosmos is full of surprises. Every star, from tiny red dwarfs to massive supergiants, has a life story. Some fade gently as white dwarfs, others explode as supernovae, creating neutron stars or black holes. But the story of stars is also our story. The atoms in our bodies were forged in ancient stars and scattered across the galaxy. We are literally made of stardust, children of the cosmos. By studying stars, we learn about our own origins, and the history of the universe. Telescopes let us look back in time, piecing together the cosmic puzzle. The light from distant stars carries secrets about the past, waiting to be discovered. Next time you look up, remember, you're seeing the ancestors of our world. Let the stars inspire wonder and curiosity. There are countless stories still hidden in the darkness. Our journey through the stars is just beginning.